Coefficient of variation and its application. In this video, we will look at the coefficient of variation and its use. So far, we have looked at measures of dispersion such as range, mean deviation, quartile deviation, and standard deviation that have the same unit as the coefficient of variation. But there could be times when you must compare the dispersion of two data sets whose units differ. Let's look at an example to see how the coefficient of variation helps in comparison. In a factory, the units of different materials used in production vary. The consumption of certain materials is quantified in weights or volumes, while the consumption quantities of packing bags are in numbers. To compare the dispersion in consumption, we use a coefficient of variation. It is the ratio of the standard deviation to the arithmetic mean expressed as a percentage. The ratio is dimensionless and is amenable for comparison. The coefficient of variation can also be used as a measure of consistency. For example, when two data sets represent scores of two individuals, the individual with a lower coefficient of variation is considered more consistent. Considering the same datasets from the previous video. I5, 15, 15, 25. 2, 10, 15, 15, 20. You know that the mean of both datasets is 15, and the standard deviations obtained earlier are 7.07 and 3.53. Hence, the values of the coefficient of variations are 47.13 and 23.53 respectively. The second individual is more consistent. The data set with a smaller coefficient of variation is less dispersed than the data set with a larger coefficient of variation. This is how you use the coefficient of variation for different scenarios.